Welcome to the PH4410 review on the planar maximally filtered graph, also called the Pmfg. Now, in previous video reviews, we have already gone through spectral filtering of a cross-correlation matrix, threshold filtering of a cross-correlation matrix, as well as the more sophisticated minimal spanning tree filtering of a cross-correlation matrix. Now, the success or the utility of the MST in filtering cross correlations, keeping only those most important, well, you would think that it will lead us to think about whether there is a more systematic way to keep more and more correlations. So we start off, of course, with the MST. Okay. Now instead of the full n times n minus 1 divided by 2 cross correlations in a correlation matrix, the MST keeps only n minus 1 of them. So this is of order n, and this is of order n squared. So a lot of cross correlations have been thrown out, and we wonder whether we could keep maybe more cross correlations than those emitted by the MST, but still small in comparison to the total number of independent cross correlations. And very recently, Professor DiMatteo proved that this can be done. This can indeed be done, and the way to do it is to embed the links onto surfaces with different genus. Okay, and when we add holes to a surface, we find that it is possible to add more and more cross correlations without them actually crossing. When we add more and more holes onto a surface and then keep important correlations, we realize that we can keep more and more links without them ever crossing each other. So the crossing condition is not allowed for such embedding of cross correlations. And a genus, of course, is the genus of a surface is, of course, the number of holes in the surface. For example, if I have a sphere, okay, this doesn't look very spherical, but topologically it is equivalent to a sphere. And if I have one node here, another node here, another node here, another node here, and maybe one node at the back, I can connect them. I can link them without the links ever crossing in such a way. And of course, I have to choose between this link versus other links. And this one will go behind to the other side, and so will this go behind to the other side. And maybe this one will go behind as well to the other side, and this will go behind to the other side. So these nodes are actually distributed on the surface of a sphere, and the links that we have just drawn, they actually do not cross each other. Okay, so this is, and a sphere of course has G equals to 0. It has 0 genus. Okay, and if I want to do this same embedding onto a surface with genus 1, then I will need to do it over a donut. This has G equals to 1, and this is a torus. Okay, and then of course I can then distribute my points here and there and everywhere on the surface of the donut. And I realize by adding a hole, I can prevent certain links from crossing each other. So in that sense, I could add more and more links to I can keep more important cross correlations. And then for a surface with genus 2, it will look something like this. So 2 connected donuts. this will be genus equals to 2, and you can, if you embed the links from the cross correlation matrix onto this surface, you find that you are able to keep even more important cross correlations. Now, for a sphere, you realize that you can actually keep 3n minus 6 links for n nodes. So that is a significant improvement over the minimal spanning tree, where you can only keep n minus 1, and it is still small compared to order n square because it's only order n. So you keep a small number of links, more than you keep for the MST, but still small compared to the total number of independent cross correlations. Now, let me demonstrate how we would go about constructing the Pmfg. We will start by giving the algorithm, and the algorithm turns out to be very similar to that of the MST. So one, you will start from the maximum Cij, and then you will draw a link between I and j. Okay, then you go to the next largest Cij, and if the new link between I and j keeps the graph planar, accept the link, else reject. Okay, so instead of no cycles, now the condition for accepting the link is that the new link added keeps the graph planar, and then step number 3, we will stop if all nodes are incorporated into a single graph. Okay, else go to back to 2, and you repeat until you have exhausted all the nodes, and it's therefore and it's also important to realize that the MST is a subgraph of the Pmfg, because certainly the tree condition is planar. If you all the links that you accept for the MST, they will not make the graph out non-planar, so therefore they are also accepted into the Pmfg, which is why the MST is a subgraph of the Pmfg. Now let's do an example.